CH3. Now you have stuff like this and you want to name the compound. So I hope everyone can hear me clearly. So I want to start by naming the first compound here. What I have here, that is organic compound 1. So to name this, what I do is to identify the longest carbon chain. So to identify the longest carbon chain, we are talking about the carbon with the highest number of carbon, the longest straight chain carbon that does not break. So if you look at this compound, let me rewrite it here. We have it as CH3, CH, right, CH, then you have a CH3, then you have another CH3, then you have a CH3. You have something like this, and there is a need for us to actually work on it. So what are we supposed to do? The first thing is to, you can restructure it if you think it's going to give you challenges. How do you restructure it? You can draw the skeletal structure like this, C with 3 carbon atoms, right? The first carbon is having 3 hydrogen like this. The second one with a CH and a CH3 like this. The next one with another CH and another CH3. Then this is a CH3 like H, H, H. Now I've broken down this into the simpler form. So the next thing to do is to identify the longest carbon chain. So if you look, I think the longest carbon chain is actually 1, 2, 3, 4. So this is the longest carbon chain. 4 carbon atoms connected. So now since the number of carbon is 4, so it's going to be the parent name will be a but. So, and it is a carbon-carbon single bond, so it's a butane. Right. So that is the first thing to do. It's a butane because it has 4 carbon atoms. The next thing to do is to identify the substituent. Now there are 2 major substituents here. You have a CH3 here, and then you have another CH3. Hydrogen is not a substituent. So the substituent we are having there is a methyl, CH3, which is called the methyl, or some people call it methyl, as the case may be. Now the next thing to do after identifying the substituent is to give the numbering, the lowest numbering possible. So for this, if I want to give the lowest numbering possible, I'm going to start from left to right and from right to left. If I'm counting from left to right, this carbon is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. So look at the position of your substituent. The first substituent here is on position 2, so I write 2 here, plus the second substituent here is on position 3, plus 3. So add the 2 together, that gives me 5. Now if I take the other position, which is from right to left, so this is carbon 1, carbon 2, carbon 3, carbon 4. So the substituents are on position 2 and position 3, which is also 5. So either I go from left to right or from right to left. It's the same numbering, so I can take any of the routes. Now if that is the case, I'm having 2 of the methyl on position 3. So I have 2 methyl. Then I have another methyl on position 3, so I have 3 methyl. So since I have 2 substituents, right, 2 same substituents, so I can collapse the numbering and give it a di referring to as 2 substituents of the same type. So this becomes a 2,3. Because they are both methyl, it's going to be a dimethyl. So the substituents here are 2,3-dimethyl. So to name the whole compound, it is going to be 2, 3 dimethyl. Then you write the parent name. The parent name is butane. So the name of the compound is 2,3-dimethyl butane. Is that okay, everybody?
Yes, sir.
Okay, we move to the next one. The next one is this. Let me pick this one as the next one. This is number 2. That's a CH3CH. Okay, let me take it here. You have CH3, CH, there's a double bond, CH3, and a Cl. Now we can see this is definitely an alkene, meaning that it has a double bond. So we can redraw the structure, the skeletal structure. So this is going to be a C with 3 hydrogen, H, H, and H. Then you have C, then H up here, and then you have what? A double bond. Then you have another C with a CH3 and a what? Cl. Now you can see that all the carbon have 4 different bonds, so meaning that every carbon atom must have 4 bonds. If it does not have up to 4 bonds or more than 4 bonds, that means the compound is not appropriate. So you must ensure that the carbon atom has 4 bonds. So the longest carbon chain here, just like we did for the first one, is this. So the longest carbon chain is also 4, right? Now, but in this case, because it's an alkene, it has a double bond. You must ensure you before you look for the substituent, you must look for the position of your double bond. That is very, very important. So if I want to go by the position of the double bond, I start from right to left and left to right. So let's take it from left to right. Carbon 1, carbon 2, carbon 3, and carbon 4. So my double bond, which is the functional group, is between carbon 2 and 3 from left to right. So I go for 2. 2 is smaller than 3. Then if I take the other position from right to left, this is carbon 1, carbon 2, carbon 3, and carbon 4. So looking at that too, you get to realize that the double bond is between position 2 and 3. So I go for position 2, which is smaller. So you can see both positions are 2, 2. But you are not going to conclude yet, because there is a substituent. So the substituent that is now present will now tell you where to go. Assuming one is 2 and the other is 3, then you go for that 2, and that is the position you will take. But since both positions are 2, 2 for the for the functional group, which is the double bond, then the next thing is to identify the position of your substituent. Now let's look at the position of our substituent. Our substituent here is what? Cl. So what is the position of the substituent from left to right? So this is carbon 1, carbon 2, carbon 3. So carbon 4. My substituent is on carbon 3. Now if I take the other position, what is the position of my substituent? Carbon 1, carbon 2, carbon 3, and carbon 4. My substituent is on carbon what? 2. So this is smaller than this. So overall, I'm going to go for position 2. I mean from right to left. So going by that, let's go back to the naming. There are 4 carbon atoms in all, so that's the boots. So the parent name is boots. It's a butene. But what is the position of your ene? You can see that the double bond is between 2 and 3, either from right to left or from left to right. So the parent name is going to be but2ene. We have ascertained this before now. Then looking at the position of your functional group, so we said you go for position 2 neglecting position 3, and so the substituent is actually a chloro, so it's a 2-chloro. So the name of the compound will therefore be 2-chloro. 2-chloro what? But2ene. 2-chloro but2ene. Is that clear, please?
Yes, sir.
Okay. Now, Fatia, can you try this third one? This compound 3. Shall I give you time to try it? Let's see what you will get.
Okay.
Yeah.
3 bromo.
3 bromo.
4 chloro.
4 chloro.
X 3 ene.
X 3 ene. Okay, let's see if that is correct. Yeah, I'm going to do it right from where we have the slide. So let's identify the longest carbon chain. 1, 2, 3, 4, 5, 6. H3. CH2. I can hear somebody talking about pepper. CBr. Double bond. CCl. Then CH2. Then CH3. So this is what we have. So How do we then get the nomenclature of this? The first thing we do is to identify the longest carbon chain, and to do that we just count the longest chain: 1 2 3 4 5 6. So it is continuous, so this is the longest. So how many carbon atoms? That's 6 carbon atoms. So the parent name is a hexene. Hexene, because it has a double bond, so it's an hexene. But we need to know the position of the in, which is quite essential. So we need to number it from right to left and from left to right. So if you are numbering it this way: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So our double bond is between 3 and 4, so we take 3. Now if you are taking the other positioning, so this way: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. It's also on carbon what? Between 3 and 4, we also go for 3. So we can see in both cases it is still an X3 in. The position of our in is what? Position 3, so it's an X3 in. However, there is a need for us to now finalize with the positioning of our what? Double bond. I mean the position of our substituent. We have two substituents. One is here and one is here. Are you paying attention? So if you are
Yes,
taking
sir.
it this way, right? So the position of our substituent, position 3 plus position 4. So that will be 7. If you are taking it the other way, it's also going to be position what? 3 and position 4. It's also going to be what? 7. Are you following? Now it means both positions are corresponding. Position 3, position 4, position 4, position 3, they are the same word position. So in that case we can name it either ways. So it means if I'm taking this position here, this is going to be a 3 bromo. That's my substituent, and the other one will be a 4 chloro. So alphabetically I'm going to start with the bromine, so that will be a 3 bromo. Oh, a few seconds please. It will be a 3 bromo, then 4 chloro. Then the compound is a what? It's an hexene, so this is going to be X3 in. I think you got it correctly. Is that right? 3 bromo 4
Yes,
chloro
sir.
X3 in. Oh, perfect. I love that. Mashallah. That's interesting. So now the last question here before we proceed is the one we have here, and this one is quite easier because it's an alkane. So if we are to name this, let me name this one here CH3 CH3 Br. Okay, then I have a CH, then I have Cl, then I have CH2, then I have CH3. Are we together? So the longest carbon chain is 1 2 3 4 5. 5 is the longest carbon chain. Okay, now let's do the numbering. Okay, from left to right and right to left. This is from left to right: carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Well, since it's a 5 carbon atom, let's write the parent name. Is carbon single bond, so it's a pentane. Now let's look at the position of the substituent. One is here, one is here, one is here. So 2 plus 2, then plus 3. So 2 plus 2, that's 4. 4 plus 3, that's 7. So from left to right, 7. Let's take it from right to left. So carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So that is position 3, plus position 4 plus 4. So this is 8 plus 3, that is 11. So which one is the lowest numbering possible? 7 is lower than 11. So I go for 7 and neglect 11. So to name my substituents, these are the substituents that I have. So the first one is bromine, that's a 2 bromo, position 2. Then I have a 2 methyl. Are you following? Then I have a 3 chloro. So I need to arrange them alphabetically. So to arrange them alphabetically, I'm starting with the bromine. So the name of the compound will be 2 bromo. Then I have 3 chloro. Then I have 2 methyl, right? Pentane. So this is the name of the compound. Amazing, right? It's very long but quite easy. Are we together? Can I proceed?
Yes, sir.
So this is actually
Yes,
a
sir.
review of what we done in the last class. So let us start with cyclic compounds. So what we mean by cyclic hydrocarbons here, we are talking about hydrocarbons that are enclosed, right? So meaning that they they are mostly forming an encyclic, that means they are forming a cyclic ring, or we say they are forming a what, a ring. So they are always closed, so we call them cyclic. And the simplest of them must have 3 carbon atoms. Please, I guess you are listening.
Yes, sir.
For example, we can have a carbon this way, another carbon this way, another carbon this way, and they get encircled. Now in this situation, all the carbon atoms are closed, and then each carbon atom, carbon single bond, so it's an alkane, but it's a cyclic alkane. It's a cyclic alkane. And so every carbon must have what, 4 bonds. So if I'm to complete this, I have to add 1 to hydrogen, then another hydrogen and hydrogen, then another one here, hydrogen and hydrogen. So that gives me a complete structure of this. Now this sometimes can be drawn this way, like triangle. So what is triangle is not just a triangle here, it is a cyclic compound. Okay, so where each of the junctions represents a carbon atom. So this one, there's a carbon here, there's another carbon here, there's another carbon here. So summarily, every carbon atom here having a 4 bond, so it's going to be like this. I hope that's clear, showing that it is a cyclic hydrocarbon or a cyclic alkane. Please, are we following? Hello?
I didn't get my network. I really get.
Yes, sir.
Okay, fine. Now, this carbon atom has how many bonds? 3 bonds. So because it has 3 bonds, so the parent name is what? Is an alkane. So is a propane. You know, when the number of carbon is 3, that's a prop. Because carbon single bond is a propane, but it's going to be a cyclic propane because it is what, enclosed. The carbon atom are enclosed. So this is called cyclopropane. We call this cyclopropane. So we can continue to have a lot of ring or cyclic alkane structure, right? The minimum, just like I said, is what, 3. So we can have 4 like this, enclosed, like a square or a triangle or a rectangle. So this is another one. So can anyone guess what the name of this one will be? Yes, this is going to be a cyclobutane. Now it can also be drawn this way with 4 carbon atoms, so you can have it like this. See that? So like a square or a rectangle. Okay, so now you can even have a cyclopentane also. It's just following you realize that my cyclopropane has the same molecular formula like that of an alkene. For example, this is C3H6. See that? This one is going to be C4H8. Okay, now if you look at cyclopentane too, okay, this is a cyclopentane. Now as for cyclopentane, I have each carbon atoms here: 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon atoms. So each will have hydrogen saturated to make it 4 bonds. So I have 1, 2, I have 3, 4. This is 3 and this is 4. This is 3 and this is 4. This is 3 and this is 4. So this is the structure of cyclopentane. This is cyclopentane. Okay, this is cyclopentane and it is C5H10. Now looking at all the compounds, there is one fundamental thing you will get to realize, that all these cycloalkanes, they have the same molecular formula as that of the what? Normal alkane structure. So for example, if you look at the alkenes generally, the alkenes has a general formula which is CnH2n. We've done that in our previous class. So if n is equal to 3, for example, you are going to have C3H what? 2 bracket 3, which will give you C3H6. Normally this compound is a propene because it's an alkene. However, if you look at the cycloalkane with 3 carbon atom, which will give us like a triangle like this. So what will you realize? You realize that this carbon HH like this. So if you put the hydrogen, what will you realize? The carbon here is 3, hydrogen is also 6. So the molecular formula for cyclopropane, right, which is C3H6, is the same as that of what? Propene. Despite the fact that they don't have the same functional group. One is an alkane and one is an alkene. But because it's a cycloalkane generally used to have the same molecular formula with the straight chain or the normal alkene compounds. Am I communicating, please?
Yes, sir.
Okay. And then I have something on top which is like a CH3. Don't forget that the CH3 there is already a substituent. So my carbon atom here, another carbon atom here, another carbon atom here, it is closed this way, and there is now a CH3 up here. So whatever I have here, I can, this is 1, 2, 3, I put 1 here to make it 4 bonds. Carbon 1, 2, 3, 4. Every carbon must have 4 bonds. This is 1, 2, then this is 3 and 4. So I have redrawn this structure this way. So looking at that structure, you know there is a cyclic compound there, and the cyclic compound is this in a triangular form. So that's a cyclopropane. So that is my parent's name. However, there is a substituent that is attached. So looking at the substituent is a CH3 substituent, and that's a methyl. CH3 is a what? Is a methyl. So it means the name of this compound will become methyl cyclopropane. Now you necessarily do not need to put the number, and if you want to put number you can, because this is the only methyl that is there. So that's why I just decided to write it as methyl cyclopropane. Okay, but if you can write it as 1-methyl cyclopropane, you are still correct. However, if you have the same compound with two functional groups, I mean with two substituents of the same types, for example, you have a CH3 here and then you have another CH3 here. Now in this case there are two functional groups, one substituent here, I mean there are two substituents, one is here and the other is here. So it is still a cyclopropane, but one of the substituents is on position 1, this is position 2, and this is position 3. So to name this now, your substituents would be 1-methyl, right? That's the first substituent. The second substituent is a 2-methyl. Now because they are the same type of substituent, you name it as 1, 2. Then because they are the same, it's going to be a dimethyl. So the name of the compound will become 1, 2 dimethyl, right, cyclo, right, propane. Please, does that make any good sense?
Yes, sir.
Now if you if you
3
1, 3
di methyl.
Is somebody telling you? I can hear somebody's voice.
No.
Dimethyl
Butane. Cyclobutane.
Yes. 1, 3 dimethyl cyclobutane. You are correct. So let's listen. 1, 3 dimethyl cyclobutane. This is correct. Can anyone try this one? It looks like a rectangle with one double bond. A triangle, I mean, with a double bond. How many carbon atoms? Are you listening?
3.
Yes, so and it is enclosed and it has a double bond. So what do you suggest it will be?
Cyclopropene.
Very correct. Very correct. So this is going to be a cyclopropene. Why? Because it has a double bond. So it's going to be a cyclopropene. Cyclic because it's enclosed. Propene because it has 3 carbon atoms enclosed with a double bond. Okay, so that is cyclopropene. Alkanols. Okay, they are sometimes called alcohol. So alkanols and alcohols are special organic compounds, and you also need to know how they are named. So how do you identify them? You identify them by seeing OH. Whenever you see OH, it means that thing is an alcohol or an alkanol functional group. Sometimes they call it the hydroxyl group. So that's the functional group. Now whenever it is present in a given compound, so the word "or" comes out in the naming. For example, you have a carbon atom and then you have OH attached to it. So this is going to be, don't forget that carbon must have 4 bonds. So this is going to be H, H, H. So there are 4 carbon atoms there, complete. Okay, I mean 4 bonds connected to the carbon. So this is complete this way. So this is having just 1 carbon atom. So this is going to be what? Methanol, because it's an alkanol. So if you have to, this one can also be drawn as CH3 because this carbon, the first carbon, is attached to 3 hydrogen, then with another OH attached. So this is methanol. So this is it, either it is written this way or this way, it's the same. So we can have 2 carbon atoms like this, C with another C. Okay, so okay, before that, this one sometimes they can name it hydroxyl methane. Okay, but this is not it's not an IUPAC name. They can call it hydroxyl, are you together, methane, meaning that a methane that is having hydroxyl. Okay, are you getting it? But that's not the common IUPAC name. This is the IUPAC name, methanol. Are you getting my explanation? So we can have 2 carbon atoms attached to this way, right? So this one, 1 2 3 4, 1 2 3 4, but it's going to have an OH attached. Please, I guess you are getting it. 2 3 4 5. Okay, the first carbon atom is having 3 hydrogens, CH3. The second one has 2 hydrogens, CH2, and the last one has just OH. You can say the CH3CH2OH is having 2 carbon atoms. So since it is having, it's an earth. So because it's an alkanol, it's going to be ethanol. So this is ethanol, CH3CH2OH. Sometimes it is written as C2 because there are 2 carbon atoms, H5, 5 hydrogen, then OH attached to it. So this is ethanol. Okay, so we can continue to have the same system of naming. CH3, right, CH2, right, CH with 1 OH here, right, then a CH3. Now what happens if I have something like this? You can see that I'm having 1 OH also added to this part. Now for me to work on this, normally I follow the rule. The rule is that you identify the longest carbon chain, but before then you could decide to draw the skeletal structure so that you not get confused. The first carbon atom has 3 hydrogens, 1 2 3. The second one has 2 hydrogen, 1 2. The third one has 1 hydrogen up, 1 OH down. Then you have H here, and 1 H here. So there are 4 carbon atoms, so we have it this way. So this is 1 OH here. So this is a propanol. This is called what? Prop because it has, but because it has 4 carbon atoms is a butanol. But most importantly, we need to know the position of our ore, because the position of our ore is quite critical. Is the position of the functional group. So how do we get to know the position of the ore? By naming from right to left and left to right. So if you are naming it from left to right, this is carbon 1, carbon 2, carbon 3, and carbon 4. So this is going to be on position 3. If you are naming it from right to left, you are going to have, okay, you are going to have this carbon 1, carbon 2, carbon 3, carbon 4. It's going to be on carbon 2, okay, OH. So you go for 2, you neglect what? 3. So the position of our ore is going to be on position 2. So this is butan what? 2 ore. This is called butan 2 ore, or we call it what? 2 butanol. 2 butanol, because the position of our ore is on position 2. Okay, I hope that's clear.
Yes, sir.
CH3 CHOH CCH3, right, CH3 CH3. Now this is an organic compound, so we can name this organic compound also. It's an alcohol because it is having OH group. So to name this, what do? We identify the longest carbon chain. 1 2 3 4, 1 2 3 4, either of the. So I can pick this longest chain this way. Okay, so I'm having 4 carbon atoms, so the parent name is a but. So but because it is having an OH group, which is an alkanol, So I need to identify the position of the ore. So I know it is a boot, but I don't know what boot it is. So butan what? So let's try to get the positioning. So if I take the position from left to right, this is carbon 1, carbon 2, carbon 3 and carbon 4. So my OH is going to be on position 2. If I take the numbering from right to left, this is carbon 1, carbon 2, carbon 3 and carbon 4. So my OH will be on position 3. Okay, so it therefore means that I will neglect this position and I go for this position. If I'm going for this position, this is butan 2 or, and so I will continue with that position because the functional group will determine, the smallest functional group will determine the positioning of the other substituent. Therefore the other substituent, one is here and the other one is here. So the first substituent is on position 2, so that is a 2 methyl, sorry, position 3 from left to right, so it's a 3 methyl. The other one is also on 3 methyl. So this becomes 3,3 dimethyl. So the name of the compound now becomes what? 3,3 dimethyl, okay, dimethyl butan 2-or, butan 2-or. This is the name of the compound. 3,3 dimethyl butan 2-or. Is that okay? So if you have something like this, C OH here with another OH here with a what? Br here and H here, H here, H here, H. Now for example, they can write this compound in a way like CH. You can write it as CH2OH like this. They'll write it as CHBr and what? CH2OH. It's the same, this or this, they are the same compounds. So if I want to name this compound, or what do I do? So what are the principles to be adopted? First is that I will identify the longest carbon chain, which is 1, 2, 3. So that's the longest carbon chain. So it has 2 OH group, one OH here, another OH here. Okay, so if that is the case, this is going to be a diol. We call it di, 2 what? Or. So it's a diol. So we don't always put hyphen, we put it as diol. So what is the meaning of diol? 2 alcohol functional group. So if I'm to name something like this, I can name it from right to left, left to right, just like you are following the rules. So this is carbon 1, carbon 2, carbon 3. So my or is going to be on position 2, position 1 plus 3, so which is 4. So if you go this way too, it's going to be on position 1 plus 3, which is also 4. So our OH are both on position 1 and position 3, and the substituent maintains position 2. So either ways you still have the same thing. So the name of the compound will now be what? Since it's a propanol but the functional is substituent, the substituent is a 2-bromo. So the name of the compound will likely going to be what? The name of the compound will be 2-bromo. Okay, propan 1,2,1,3 diol. So this is the name, 2-bromopropan 1,3 diol. Do you get that? 2-bromopropan 1,3 diol. That's the name of the compound. So can you try to name this? So how far so far?
3-bromo.
3-bromo, okay.
2-chloro.
2-chloro, okay.
4-methyl.
4 methyl
X two all.
x hexan 2 all. Is that what you got? Any other contrary answer? Any other answer from the others? The longest carbon chain, just like you said, is 1, 2, 3, 4, 5, 6. This is 6, the longest carbon chain. Okay. Now, the first thing to do is to identify the functional group, which is the OH here. And we need to know the position, the closest. Okay, so if you are taking it this way, 1, 2, 3, 4, 5, and 6. So your OH is on position 2. So definitely you are going to go for that. If you are to take the other one, 1, 2, 3, 4, 5, that position 5. So we can't go for 5. We maintain 2. So if you are maintaining 2, so it means the parent name is going to be an hexan, right? Hexan 2 or, right? So that's the position of our or. Then we now take the substituents. What are the positioning of our substituents? The chlorine here is on position 2, so that's a 2-chloro, right? The bromine here is on position 3, that's a 3-bromo. Okay, so we have another what, CH3 here, that's a 4-methyl, right? So we need to arrange them alphabetically following the order, alphabetical order. So we start with 3-bromo, followed by what, 2-chloro, followed by 4-methyl, okay, then what, hexan 2-or. So that is perfectly correct, mashallah. That's a good one. Okay, fine. So we can proceed with another functional group. Yeah, the time is really going fast. Alkanoic acids. So how do you identify the alkanoic acid? The alkanoic acid has a functional group COOH. They can also call it carboxylic acid. Okay, they call it carboxylic acid. So another way of drawing this is a C double bond O, then with another OH. So like this, C double bond O OH. So the name of this compound, how do we name that? So the simplest of them is C double bond O with OH. So then you are going to have one H here, showing that it is the simplest. The carbon must have 4 bonds. So it's sometimes written as CH, like this, HCOOH. So this is called methanoic acid. Meth because it is one carbon atom and it is an alkanoic acid. So if I have 2 carbon atoms, I'm going to have something like this.
Hello,
Yeah,
sir, I have a question.
go ahead please.
Do the alkanol,
Yes.
can it be that of alkene group?
I don't get that. Can the alkanols be that of alkene groups?
Yes, like
Can
can
you
it
give me
be
an example?
hexene 2 all?
Yeah, definitely. We can have multiple functional groups. So we can have an in and then we can have an or joined together in a compound. So that is going to form an enol. So now, however, sometimes
Okay.
you are asking me some questions that are a bit advanced. Sometimes when you have formation of enols, especially when you are close to one another, they undergo a process called tautomerization. They are going to tautomerize
Yeah.
and then they will be converted to an aldehyde or a ketone, as the case may be, depending on the positioning of the OH and the positioning of the double bond. Now, if you have two carbon atoms, one here and two here, one of them must definitely have a carboxylic group, so like double bond O with what? OH. So this other one must have four bonds, 1 2 3 4, this way. So this is going to be H here, and H here. Okay, so the first carbon atom, this can be written as CH3 with COOH, another way of writing that. Okay, so since you have two carbon atoms there, so that is an earth, so this is going to be ether. It's an alkanoic acid, so that will be an ethanoic acid. So the chemical formula for ethanoic acid is CH3COOH. So here we have it. So we can have 3 carbon atoms, 4 carbon atoms, 5 carbon atoms, and so on and so forth. So far we are having the OOH, and it is not necessary that they write it at this end. They can begin with it too. So the principle still remains the same. So if I have it this way, okay, so that will be a CH3, CH2, CH2, COOH. This one is having 4 carbon atoms, so this is a butanoic acid. Now let me add some substituents. The C, I have a CH3 here, and I have a Br here, and I have double bond O with one OH. So this is an organic compound, an alkanoic acid. This can be written as CH3 C, right, CH3 Br, you can write it this way, COOH. Okay, so how do we name this? It's quite easy. So we follow the rule as usual. You identify the longest carbon chain, and that's just 3. Now, but in this case, our COOH is known as a terminal functional group. What's the meaning of terminal? Terminal means it's always located at the end. Either you find it at the end here or at the other end here. So either at the extreme right or at the extreme left. This is where they are positioned. You cannot find them in the middle, so they are extreme. So whenever you are naming with this, you always start from the functional group, which is the oic acid, alkanoic acid. So I always begin with this as carbon 1, carbon 2, and carbon what? 3. So looking at that, carbon 1, this one is not left to right, right to left, because the position of your functional group is the extreme right, so you take that one as your default position. So this is position 1, position 2, and position 3. Name is actually what? Propanoic acid. This is, I need to put in 1. Now the next thing is to the substituent. Now since it is this number you have taken, this one, we cannot take the other one, because it is where the extreme end started from. So it means this one is position 2, and this substituent is also on position 2. So it means the two substituents, the first one is 2-bromo, and the other one is a 2-methyl. So to name the compound, you are going to take it alphabetically. That will be a 2-bromo, right, then 2-methyl, then what? Propanoic acid. So it's a 2-bromo 2-methyl propanoic acid. That's the name of the compound. 2-bromo 2-methyl propanoic acid. Can you try to name this one? Small, yes.
3 bromo
3 bromo, sorry, 3 bromo,
2,4
2,4
dimethyl
dimethyl
pentanoic acid.
pentanoic acid. Okay, let's see if that's correct. So the longest carbon chain is 1 2 3 4 5. That's 5. So that's actually a pentanoic, as you said. That one is correct. So that means we take the position here, this position 2, this position 3, and this position 4. So yeah, you got it correctly. So 3 bromo 2,4 dimethyl pentanoic acid. Beautiful. So that was awesome.